Oh, hello. Can you hear me? I think so, yeah. So my name is Murilo. I'm a lecturer in robotics at the University of Manchester, and I've been an open research fellow with the University of Manchester for the past year or so. And I'm going to talk about open executable books in robotics. So before you take a nap in my presentation, we can go to the takeaways. So I want to show a template for executable books, how to build them, how to maintain, to introduce you to 3 books. They are not as big as books, I suppose, but they are the seeds for something bigger that I want to start building. And talk a bit about text-based notebooks and some of the things that I developed during this fellowship. So the background for all of this discussion is that, especially for robotics, but it also applies to other fields, the students, when they first get in, they have to meet with this page of equations and formula that they just look at me and they say, I hate you. So that's basically how they are first introduced to the topic. And although they need to know this, what we usually have as an issue is that they're great for written exams. So they memorize how to work those equations and they memorize what they should expect from those equations. But the exams, they don't move robots. So when I have in my research lab, I need to hire someone to help me with the research or to do the research with me. If they are book smart and they are great in the exams, it doesn't necessarily translate into being good in practice. And I noticed this theory practice gap in my group as well. So we had many good students at the University of Tokyo. They came to the group and they were great at the equations, but they had this difficulty translating that into a real robotics application. And unfortunately, we have a big demand on research that it needs to give impact very quickly now. And the same thing applies to the industry. So we cannot just contemplate for years about the equations and mathematical formulae. We need to show it doing something. And in this sense, we have this pressure to deliver more. We have to deliver better, and we have to deliver faster. And the question is not if this is needed, because it is what we do about it. So in my experience, during the shall not be named 19, I was stuck in Japan, and my students were not able to go to the university either. And I had a group of students that we had to introduce to very complicated robotics concepts, and I could not talk to them face to face. The remote communication structure was not as stable as it is now. So the idea was I make some content that they can interact with. It has the 8 lessons that they need to somehow learn from. And this means that I was happy too, because then I don't have to go through all the same content for dozens and dozens of students. The overall feedback that I received is that either they were lying to me or they were really happy about it, which was good. We had a good number of students who were applying those concepts into real moving robots. So that was quite efficient in the point of view of only me, but it was quite difficult to scale. So I was using MATLAB. MATLAB is a proprietary program. The students in engineering, in control and robotics, usually they are introduced to this, but it's not everyone who has access to it. And it also comes with a subscription fee and so on. The other difficulty that I was having is that these files, they are usually binary files, which means that they're both difficult to do version control and difficult to collaborate. So if you make a modification in your file and I make one in mine, you cannot easily merge those changes because the entire file has changed. So the requirements that I had in mind when I started with this project is that it needed to be something that was going to be useful for teaching and research. So it needs to go all the way from PGT to the PDRA levels of research. Whenever I have a new member in the group, they can take advantage of that. Something that just works, so I cannot need something that they need to install software, or I need to explain them how the software works, or you have any complications in that regard, because that hurts both accessibility and maintainability. To be able to see probably for math, because those equations, even though they're scary at first, they are the only way that the robot is going to move properly. So they need to understand why that's happening. And in the point of view of maintainability, as the person who is keeping those books alive, it needs to be something that is somehow stable after I set it up. I can focus on the content, and I don't have to think about HTML and CSS files and all that stuff. That for me is just, black magic. So you can just give a dramatic pause. So if you want to open the website, and hopefully this is not going to be, a weird moment in which nothing works, but I don't know what's happening. Just let's look at some faces and see if it's okay. It opens. Great. That was a little risky, but I had a video too. So the idea here is that you have an introduction of all the contents of the book, which ideally is going to be divided into many different ones. So you can have a summary of lessons per book, not very common, reasonable structure. But the important thing is that you have the math rendering in the page so that people can see what I'm talking about together with graphs and explanations of how things are working. And the benefit of this is that together with the equations and the math and so on, you also have the code that they can interact with. In this type of deployment, you can also execute it into your browser. So you can click and see things happening there. I still have not taken fully advantage of this. You can execute and see what happens, but it doesn't have a lot of interactivity yet. And you can also open as a binder notebook, basically. So you open the entire workspace, and you have access to all of that content, and you can play with. And lastly, you have instructions to make your own. Not so much instructions in the point of view of starting from scratch, but sometimes we see some finished products, and we wonder, how did you get to that stage? And I'm trying to explain that both to you and to myself in 1 year, because I will forget. So about the content, I'll just go through all those one by one. And the idea is that we use the basic lessons for the first half of the robotic manipulators unit. It's currently live, so we are using it already for teaching. I have the advanced lessons that originally I created 4 or 5 years ago, and I wrote them again in Python and made some adjustments. And I'm trying to add to this the concept of one major paper, one chapter. So every time that we have a good, interesting paper, I don't have to teach people how to do it again. I can just make one lesson, a tutorial about how it works, and then they can figure themselves out. And the concept of having an explanation of how I made choices about the style of how things are presented in the book and how you can make your own. So the solution, I'll not go too much into detail, but the idea is that I'm trying to break things into everyone's jobs. So the writer job is just to make the content. That's the dream, right? So I just want to think about the robot moving. I just want to think about the equations or the insights about the formula. I don't want to be worrying about if the dark mode is going to work today, if the light mode is going to if this figure is going to go well with the light mode. I don't want to think about that. I want to worry about the content that I want to deliver. And then using Jupyter Notebook 2.x, whatever version they come up with in the next months, you can create everything almost automatically using GitHub Actions. Then this is generated for you. You don't have to do anything. I also didn't have to do anything because of Jupyter Book, which is great. You just configure a few files. You publish to GitHub Pages, and the person can just look at it and interact with the content. So the writer's job, the idea that I'm trying to work on is the live single point of truth. So whatever you see in the website is what I have for you. There is no hidden version. There is no working version. Whatever you see is what I have. So if you find a mistake and you tell me, I can just fix it right now. There is no intermediate thing holding us back. And this did happen a few times. I did some edits during the lab sessions. They found some typos or some part was misunderstood. You can just regenerate quite quickly. And if you're lucky enough to be able to do some text-based notebooks that I tried to introduce, then you can do changes directly on GitHub. So this was all made possible because of JupyterBook 2.x. If I'm not mistaken, the first public alpha version was in November last year. So I was lucky in this regard that I could have access to all of this. You can take a look at the documentation, and it's quite powerful. So it has support for regular Jupyter notebooks, has support for text-based notebooks. And even though it's in alpha, it's really good right now. Regular notebooks are what we frequently just call them as Jupyter notebooks. They are quite easy for users. So they are self-contained. You download it, you click, and it works. They embed the images, they embed the results. So they are quite self-contained. But as I was explaining earlier, very difficult to collaborate on. So if you make a change and I make a change, you're going to have a lot of conflicts there. And the files become very big. So if you have a large graph or large image, you're going to have very large notebooks, even though that doesn't affect the content necessarily. The idea of text-based notebooks, and I think they're going to gain more and more traction, is that instead of you having an environment like this into everything is rendered in front of you, you have access to textual representation of things. So it's quite useful from the developer point of view. You don't have to replicate code and so on. So it's quite handy. But it's not fully supported. Some parts are difficult to do. So for now, I'll be working on this hybrid way of having some binary notebooks and some text-based ones. As part of the development, I had to make this graphics library just to show some robots moving, just to show some elements, just to show some things to explain how robotics works. It's not something very complicated in the point of view of graphics. It needs to run on your phone, and hopefully it doesn't make your phone catch fire. So it needs to be something really simple. GitHub Actions, very good, saves my life every day. So whenever I make a change in the notebook, you push, and GitHub Actions is going to generate the page for me. So in the point of view of the developer, it's quite easy. I just write whatever I want. And if this video cooperates, yeah, you see that things are happening there. And GitHub Actions is taking care of this compilation. Usually it will take about 15 minutes because you will rerun every single notebook to make sure that whatever you see is the latest version in the website. So what's missing? In the point of view of the development that I've made so far, I think the biggest drawback in the point of view of what is not there yet is the interactivity. It's not clear to me yet what the students want to see as interactivity. I had that previously, but they didn't use it. So I had this slider, nobody ever touched that slider. So I don't know what is the best thing that we can do in the point of view of making interactivity that really matters. I don't have the answer for this yet. And for now, I promised I would hold a workshop about this, so I shall. I'm presenting the results. See today, see me here now, hey. And engage with the community so we can keep this alive. So the only way that this can be kept is if we have more people involved and more people using and more people complaining on my GitHub that something's not working. So this is the dream. And just going back to the takeaways. So a template for you to build your own books. I introduced the 3 robotics books and some of the support infrastructure. And that's it. Thank you very much.